Hello, we know Arrhenius equation, that is K is equals to A e to the power minus Ea by RT. When we are learning Arrhenius theory in chemical kinetics, directly we take this expression. Actually, how it comes? The derivation part of Arrhenius equation. Let's go with this. It's little interesting. A plus B gives rise to C plus D. A and B are reactants, C and D are products. Now, rate of forward reaction is equals to, this we are taking from chemical equilibrium, K1 into concentration of A and B. Similarly, rate of backward reaction is equal to, this is all known to you, K1 already over, so this is K2. Equilibrium concentration constant K1 is equals to K1, Kc is equals to K1 by K2, which is equals to concentration of C D by concentration of A and B. Well known to you. This is all well known to you. Equilibrium concentration constant Kc is equals to K1 by K2, that is equals to concentration of C and D by concentration of A into B. Fine. Kc equilibrium concentration constant. This is all taken from chemical equilibrium first year. Now here we are applying Van 't Hoff equation. What is Van 't Hoff equation? D ln Kc by dt is equals to delta E by RT square. D ln Kc by dt is equals to delta E by RT square. Now Kc value we are taking from this expression. Let us say this is expression 1. From equation 1, Kc value we are taking and we are going to put here. Then how it becomes? D ln, in place of Kc we are writing K1 by K2, K1 by K2 by dt is equals to delta E by RT square. Right? Very simple. Now, in place of this, you can write now K1 by K2. This can be written as D ln K1 by dt minus D ln K2 by dt is equals to delta E by RT square. D ln K1 by dt minus D ln K2 by dt is equals to delta E by RT square. Correct? Done. Up to here it is done. Van 't Hoff says now this equation can be split into two equations. This equation you can write into two equations. That I will write in another page. Just according to Van 't Hoff, you can split the equation into two of D ln K1 minus dt by minus D ln K2 by dt is equals to delta E by RT square. This equation can split into two. Fine. This is given by Mr. Van 't Hoff. So look at this. Very simple. It is to be continued. I am just giving you again. A plus B gives rise to C plus D. Rate of forward reaction is equal to K1 into concentration AB. Backward reaction K2 into concentration CD. Equilibrium concentration Kc is equal to K1 by K2. And for this we are applying Van 't Hoff equation. We are getting this one. Done? Chalo. When this splits into two, you can write the equation as D ln K1 by dt is equals to E1 by RT square plus I. I is a constant here. D ln K2 by dt is equals to E2 by RT square plus I, where I is going to be constant. Delta E, we know delta E is equals to E2 minus E1 or E1 minus E2. You can say change in energy. Delta E is equals to E1 minus E2 and I is going to be constant. Experimentally, it is observed that I is independent of temperature. Independent of temperature. Clear? So these equations can be written like, when I is independent of temperature, you can say d ln k1 by dt is equal to E1 by RT square, d ln k2 by dt is equal to E2 by RT square. Clear? Because this term we have removed, because I is independent of temperature. Integrating these equations, you can say ln k1 is equals to minus E1 by RT plus constant A. Similarly, ln k2 is equal to minus E2 by RT plus constant A. Right? Very simple mathematics, na? Now from this you can say simply k2 is equal to A E minus E2 by RT, k1 is equals to A E minus E1 by RT. So in general you can say AE to the power of minus EA by RT. This is known as Arrhenius equation. You generally don't get this derivation, that's why I am giving you here, where A is pre-exponential factor. Exponential factor, or you say frequency factor. Meaning is, it gives you binary correlations of the reacting molecules. So pre-exponential factor, or you can say frequency factor. EA is energy of activation, activation energy. K is equal to AE to the power of minus EA by RT. This is known as Arrhenius equation, and this is the derivation part. Thank you.